Ever wondered how Python just magically knows where to find things like math.square root or datetime.now? What if I told you that understanding one simple word, import, can unlock the real power of Python? Stick around because by the end of this video, you won't just use modules, you will know exactly how Python finds, loads, and links them behind the scenes. Most beginners learn import like a spell. Type it and it works. Professionals, they control their imports, optimize code, prevent naming conflicts, and structure entire projects using packages. So if you have ever seen import something dot something else and wondered what's going on, you are in the right place. Let's start small. When you write something like import math and then print math dot square root of, suppose I give a number as 25. Let me run this. It asks me for a kernel because it's the first time in this session. So let me execute this and you'll see the output for the square root of the number 25 here. Python looks for a file named math.py. When you import this, right, it looks for a file named math.py, but not just anywhere. Okay, it follows a path like a treasure map stored in sys.path. And yes, you can see that path also. I'll show that to you. Okay, if you see the output here, right, the square root of 25 would returned as 5. Now I'll show you how and where it finds the path for math.py. Okay, for that we'll have to import another library called import sys and then print sys.path. Okay, so let's execute this. So this is where red guys, okay. So if you see here, I have this 5 modules. I have many virtual environments created in this while installing this VS Code and setting up this, right? So that's Python's internal GPS for finding modules. Now that you have seen this example, how do we find the square root of a number importing the maths library? Now let's go and see how do I import the square root from the package. Okay. So what I'll do from maths, because I have already imported the math package, I am going to import from math, I'm going to import the square root. And also let's import another inbuilt function called pi. Okay. And then so you all would know the value of pi, right? Print square root, and I'm passing it as 16 here. I'll do the same for another number and then we'll print the pi value. Okay. Let's give 25 here and then I'll give print pi. Okay. Let's execute this. Okay. Now if you see, it gives the square root of 16 as 4, square root of 25 as 5, and pi value as 3.141. Okay. So we'll import one more library, very important library, and see the use of this. Import numpy as np. So numpy is a library that is used when you want to create arrays. You want to perform operations with respect to arrays. So this np, whatever you see here, np is an alias of numpy so that I don't have to write numpy dot every time. Okay, I can just use the np dot and invoke any built-in function within it. While importing this, if you get any error saying no modules found, go to the requirement.txt. So you would have a requirement.txt. You'll have to create a requirement.txt in the same folder, and there you can just write numpy. Okay. And go to the terminal, open the command prompt. So you can go here, the 3 dots above, and open the terminal from here and new terminal. Okay, so below you'll get a terminal. Now you do not have to go to PowerShell, you'll have to go to command prompt. So here is the command prompt inside Python. So we'll see where our requirements.txt is there. Let me find if I already have one. Yeah, I already have one here. So if you see, I can write numpy here. Okay. So let me just check it's inside which folder. Okay, it's inside the main Python folder. So what I'll do here is you can just do, so you already have written the numpy, and you can also mention what other, if the other libraries are not installed, you can just mention here giving a new line. Okay, then I'll have to write pip install -r requirements, requirements only, right? Requirements.txt. And if you do this, this will install the numpy for you. For me, it is already installed, so it did not give anything. Okay. So I'll tell you one other way. Instead of this requirements.txt, you can also use one other way. You can just write pip install numpy. Okay. So again, this requirement already satisfied because I already have numpy installed. Okay. So this is how you can install libraries or packages if it's not already available. If already available, you can just directly use them out here. Okay. So now let's create a new array using this numpy np.array. If you see, these are all the available inbuilt functions for numpy. Okay. Now 1, 2, 3, 4. So this will create an array for me. We'll discuss more about this numpy in the upcoming videos. Okay. So see, one array has been created using this numpy package. So I'll show you one more thing. So here what we did, from math, we are importing built-in functions one after the other. So instead of that, you can just write a star. So what this will do is it will import all the functions or inbuilt functions available in the math library. And you can perform the same function. Print square root of 16. Okay. And also you can use the other functions like print pi. It won't give an error because we have imported all the available functions within the math library or package. So it returned me the output. Now, how do I create custom or my own custom packages? These are all the available packages in the Python. So if I want to create my own package, how do I import them? Or how do I create my own custom package? So for this, we'll have to create a folder. So like I have this, if you see, I already have a folder in this 5 modules package. So you'll have to first create a folder here. So creating a folder, creating files, creating subfolders, all this I have covered in my earlier videos. You can just see them there. Okay. So you'll have to create a folder here, and then you'll have to create one init.py file. So init.py, I'll tell you the importance of this file. Without this init.py, Python won't even recognize it as a package. So now we'll have to create another .py file in the same package folder, which is maths.py, and here we'll have to perform all the related operations or mathematical operations. So we can name it as maths.py, and this init.py, as mentioned, you can keep it blank, or let me just give a comment here for this init.py. Okay. So it's a special file used in Python to define packages and initialize their namespaces. And what we'll do now is we will have to write the operations, whatever we need to perform in this maths.py. So let me create a function called addition. We'll just create a simple calculator, guys. Okay. A and B, and then return A plus B. Similarly, I'll create another function called def subtraction, and I'll pass again A comma B and return A minus B. Okay. So these are my mathematical operations in the math.py. Okay, we'll see how do we call the math.py now. We'll go to our import ipynb file, and we'll see the next steps from there. Okay. So Python actually walks into this folder that you have created, package folder. So it walks into this folder, finds the init.py, the one that we created, the blank init.py file, and only there it loads the math.py. Once it gets the init.py, only after that it will load the maths.py where we have written our operations or mathematical operations. Over here, the math.py, this file, right, this becomes our module. You can keep the init.py as empty as discussed, but you should be having this file, guys. Now let's see how do we import the functions from math.py by using the package. Okay, so what we'll do from package dot, because from here we have the maths.py, so it's recommending also the same. Okay, maths, and I want to import. We have two functions defined there. So let me just do addition import here, and I'll do addition, and I'll pass the numbers values as 2 and 3. So if I execute this should return me 5. So another way of importing packages I'll show you. Okay. So what we'll have to do, you can do from package import maths. Okay. And just by importing maths, you can just write here maths dot, and it will show you the available functions here. So for me, it's only addition subtraction. It shows both. So I can do addition, and I'll pass the same values 2 and 3. And when we execute this, it should return us 5, the same value. Okay. Now let's talk about, okay, cut this out. You can create any number of files inside the package folder. You can build any number of custom functions. Okay. Now let's talk about the common mistakes. The first one is the circular imports, where two modules try to import each other. And second module is importing too much with star. It looks messy and becomes hard to debug the code. Then wrong file structure. So Python cannot find your module in that case if you do not have the structure properly. So here's a pro tip. Always keep your imports at the top of the file and group them something like which I'm going to show. Okay. Standard libraries. So let's write down our standard libraries in the first go or at the top of the file. Import os, sys system. And then we should be writing the or importing the third party libraries. Okay. Third party libraries like import numpy as np, the one that we saw just now. And then we can import our own modules. Okay, our own modules in the sense the one that we created now, our custom packages. So from package, import maths. Okay, so this looks very clean, professional, and Pythonic. Now you know not just how to import modules, but how Python thinks when you do it. From built-in modules to your own packages, you have officially gone from beginner to import master. If you have found one aha moment today, do like this video and check out the next video where you will explore standard libraries in Python. That's where things get interesting. Don't forget to like, share, and subscribe for more smart Python explained simply.